Our astronomer Mark Thompson will be with us shortly. Tonight he's looking at the planets you can see in the spring sky and how the sight of them led Copernicus to conclusions which, correct though they were, got him in a spot of bother.
The universe, ablaze with billions of stars. It's taken us thousands of years to begin unravelling its secrets. We now have a pretty good understanding of where we are in relation to the rest of the galaxy, but in the 16th century, it was a very different story. Back then, the stars were a mystery of myth and legend. The Church was convinced that the Earth was the centre of the universe, with heavenly bodies, like the Sun and planets, orbiting around us, as the scriptures suggested. But early astronomers had their doubts. Watching the sky night after night, they were beginning to suspect that the Church had got it very wrong. I've brought a group of one-show viewers to the ruins of Llanthony Priory in South Wales. Well, here we are then in the Priory. This is, of course, where all the monks would have lived. And we can see the sky tonight as they would have seen it all those years ago. And back in those days, of course, they would have seen the stars rise in the east, move overhead and then set in the west. You can sort of understand why they'd have thought that the Earth was at the centre of the universe. But of course, people like Copernicus, he discovered that actually maybe the sun was at the centre. And what I'm going to do tonight is to give you a feel for how he might have done that all those years ago. Okay. Now, what I want to point out to you, if you all look overhead, can you see the beam from that? Yeah? Woo! And there are actually two stars in the constellation of Gemini. It's Castor and Pollux. And I'll be very careful how I say that. But it's actually the constellation of the Twin. You can see it's sort of a rectangle on its side. Yeah? Oh, yeah. Yeah? And that's supposed to be the sort of represent the two twins laying side by side. It's actually quite good because that actually does kind of look like what it's supposed to. Most of the constellations look nothing like them. But the key reason that I'm showing you Gemini is because of that object there. Now, have you got any idea what that is? Oh, you haven't got a clue, have you? No. It's Mars. Ah, red planet.
You always find Mars there in the same position?
No, it does move. It does move. And that's really the key point from thinking about Copernicus, because and they'd have looked at planets like Mars, and they'd have seen, instead of just moving across the sky in the usual sort of east to west movement that you'd expect if we were at the centre of everything, they actually kept changing in their direction. And astronomers thought that just doesn't fit with the Earth being at the centre of everything. Copernicus concluded that the sun must be at the centre, a revolutionary theory. 70 years later, Galileo proved Copernicus right by discovering moons orbiting Jupiter. That couldn't happen if Earth was at the centre of everything. Clearly, we weren't as important as we thought, and in fact, we now know we're not even that unusual. Now, if we look further over to the right-hand side, we've got the constellation of Auriga. And can you see the shape that I'm tracing out there?
Yeah. Kind of like a hexagon at the top.
Like a hexagon, yes, that's it. Yeah. It's supposed to be a charioteer. So up there is a man riding a chariot. I don't know if you can see that, but I certainly can't. Anyway, the thing that I want to show you in that constellation is that star there, which is called Capella. Yeah, can you see that? Yeah. Well, that yellow colour means that it's actually very similar to our sun, because our sun is a yellow star, and Capella is a yellow giant star. It's actually much, much larger than our sun. But the important thing is the fact that it shows that our sun isn't unique. If we'd have said that, you know, sort of 400 years ago, we'd have been burnt at the stake. I'd have been burnt at the stake, and that's not very good, is it? No. So we can see that, again, that, you know, the belief of our solar system being unique actually was quite wrong. Galileo's discoveries went down very badly with the Church. Brought before the dreaded Inquisition in 1632, he was forced to denounce his heresy and placed under arrest until his death. It wasn't until 1992, 360 years later, that the Pope apologised for Galileo's treatment. But to be fair, earth-shattering discoveries can take a bit of getting used to. It just makes you wonder what the next big discovery will be and whether any of us will believe it.
Fascinating stuff. Mark Thompson, our astronomer, is here. So that space station we keep hearing about, can we actually see that?
Yeah, absolutely. It's really easy to see in the sky. You can actually see it. This week is a brilliant week to try and find it. It's like a spacecraft. It's like an aircraft flying overhead. Yeah. And it moves quite fast. but it's a bright white light, looking like a really bright star, and it will be around sort of 7, 8, 9 o'clock this week.
OK, so you look straight up in the sky.
And you'll see it coming overhead.
And what kind of speed? Like that?
A bit slower
like that?
A bit slower than that, a bit more like that. A bit like that, yeah.
Right. Okay,
not like that.
Excellent.
Not like that.
All right, you look out for that.
I'm looking out for that.
All right, OK.
I've always been fascinated by stars and planets.
You got a particular favourite?
No, not Mars, I think.
Yeah.
Yeah,
Is that
Mars.
the chocolate? Go on, get the gag out.
No, not the chocolate. No, Mars, I think.
Yeah.
But my big hero was Patrick Moore.
Yeah,
Patrick Moore, fantastic. I used to watch that.
Yeah. Well, Mark's the Patrick Moore for this.
For the future.
Yes,
for the future.
On the 15th of April, something's happened. Something's going to happen.
Something's going to happen. 15th of April. At the moment, we can see a few planets, but on the 15th of April, you can see Mercury. And Mercury is quite a rare planet to be able to spot. Because it's close to the Sun, it's really difficult to pick up. But in the 15th of April, if you look in the west, you'll see the Moon, then you'll see Venus, really bright star, and in between the two will be Mercury. So it's a brilliant opportunity to try and find it, because it's next to some really obvious objects. So try and take on.
But how do you tell a planet from a star? I never know that.
You can tell a planet from a star. You can because you're an expert. No, you can because the planets don't tend to twinkle. The old nursery rhyme of twinkle, twinkle, little star. Stars tend to twinkle and planets don't.
That's
tend
useful.
to.
Planets don't twinkle.
Can I ask you a question? I was told that you see stars up there and the light coming to us. Is it true that that light may have left and that star may have gone?
Yeah, absolutely.
So we're seeing light of a star that isn't there anymore.
The most distant thing we can see is a galaxy which is about 11 billion light years away. So light left it about 11 billion years ago.
Oh, this is too freaky. In the light of the cosmos, even Christine's water skiing challenge is starting to look insignificant, isn't it, next to it? But
forget it.
Far from it, actually. How big are the planets to... You've done some scale models. If you scale the Earth down to that size...
You've seen the whole BBC Wonders of the Solar System, grand scale. This is a one-show version of that.
Yeah. Cheap, in other words,
cheap. I didn't like to say that.
Go on.
We've got the Earth on the side. If we scale the Earth down to that size, then that's how big Venus would be. So it's quite similar in size to the Earth. Then we've got Mars, about half the size, which is your favourite, covered in chocolate, all that sort of thing. And then we've got Mercury, which is even smaller than Mars. But that's nothing when you compare them to the gas planets, the gas giants. And we've got an amazing version.
Can we have a round of applause for this model of Saturn? Look at that. A very highly trained psychology graduate from Durham University spent the last 2 days making that. It's superb, isn't it?
And that's what licence fees go towards.
Yes.
So that would be the size of Saturn compared to those...
You wouldn't want to collide with that, would we? Gas or not?
Well, this is a balloon, so you'd be fine.
Yeah. But bigger than that would be Jupiter.
Jupiter would be about another 10 centimetres bigger, but the Sun would be about 7.5 metres in diameter.
Wow.
Colossal.
That's big, isn't it?
Huge.
Big and extremely hot, isn't it?
Very, very hot.
OK.
Very, very, very hot.
We've cleared that up then. Planets don't twinkle.
No.
I've learned
Planets
something
don't
useful
twinkle.
tonight.
Only stars.
Stars.
Stars twinkle.